Number 8 is a problem that I think if you see a problem like this, it's the quickest, easiest type of problem to do. We have a situation where the degree of the numerator equals the degree of the denominator, and whenever x is getting very large, eventually you're going to go toward the numbers, the coefficients of the lead terms. And so in this case, it seems to me that you're moving towards 1/4. All the rest of it, the adding and the subtracting of lesser terms, gets less and less significant the larger that x gets. So C is your answer on number 6. On problem 7, we've got a graph here to check out, and we're told that it's the derivative graph, so it's important that we grasp that. We're reminded of that, and we're asked to make some statements about the function, not about the derivative. So for instance, when it says the function is decreasing for this interval, well, when we think about the derivative, if it's decreasing, decreasing implies that the derivative has got to be negative. And in that interval, it seems to me that it starts out, the first part of it, from -1 to 0, it's positive, and only after 0 does it become negative. So it can't be A. F is increasing from -2 to 0. F is increasing. If it's increasing, it implies that the derivative must be positive, and if we look at the derivative graph between -2 and 0, it's positive. So the answer is B. If we want to just consider quickly the others, think about C. It says it's increasing from 1 to 2, but wait a minute. The derivative is less than 0 here. It can't increase, right? Those are in conflict. If it's increasing, it has to have a positive derivative. Decreasing means the derivative is less than 0. The next one, D, says it has a local minimum at 0. Remember what minimums do, right? Their direction goes from negative to positive, but we have just the opposite happening at 0 here. It goes from positive to negative, right? So this is the problem here. It's really a local maximum at 0. And finally, the last one, it says it's not differentiable at -1 and +1. Well, wait a minute. We've already got the derivative. It's f prime is not differentiable. The first derivative, you couldn't take the second derivative at -1 and at 1. So this is not, that's a false statement as well. So the only one that's true is B. Question 8 asks for an indefinite integral. Looks to me like substitution is in order. If we let u equal x cubed, then du has got to be 3x squared dx. We don't need the 3, right? So we multiply both sides by 1/3 to simplify it up and get our x squared dx. So first thing we do is we take our x squared dx out and we write in the place 1/3, kick that way up front, 1/3 du is the same thing as x squared dx. And then come back and write cosine of not x cubed but cosine u. That integral is sine, right? Sine u plus c, and we back substitute 1/3 the sine of u is the same thing as x cubed plus c. So when we seek out our alternatives there for number 8, it seems to me that B is the answer. Number 9 is asking us to find the derivative at 0. And the derivative at 0, well, f prime would equal, with the natural log, it's 1 over whatever you got, so it would be x plus 4 plus e to the negative 3x times the derivative of that inside, which would be, well, the derivative of x is 1, the derivative of 4 is 0, the derivative of e to the negative third is e to the negative 3x times a negative 3. So I can clean that up a little bit and write in the numerator 1 minus 3 times e to the negative 3x over x plus 4 plus e to the negative 3x. That's what the derivative is. If I want to evaluate it at 0, I simply put 0 in, right? And e to the 0 is 1, so I get 1 minus 3 up top. Downstairs, I get 0 plus 4 plus e to the 0, which is another 1. So I get negative 2/5 as my answer here. So A is my choice on number 9. Finally, number 10, we're presented with a number of graphs, and we're told that the function, the first derivative, and the second derivative are all negative. So first of all, the function has to live below the x-axis, right? This guy is less than 0. So it could be A, B, C, or D, but we quickly can eliminate D, right? It can't be E because E is positive. Now the next one says the derivative has to be less than 0. And that means there's an implication here, right, that it has to be decreasing for all values of x. So A is increasing for a while and then begins to decrease, so it can't be A. C is definitely increasing, right, so it can't be C. D is decreasing the whole time, as is B. Well, one more time here. If this guy has to be less than 0 too, it must mean that it's concave down. And on D, it's concave down for a while, but then it begins to be concave up. So it can't be D. It must be B because it's below the x-axis, it's decreasing, and it's definitely concave down. B is your answer for number 10.